All right, guys. So in this video, I'm going to expose you to probably the most useful tool in working with percentages. And this idea will make your lives a lot easier in terms of dealing with percentages of a quantity as well as later examples. And I promise in the next few videos, we are finally going to go into applications of percentages. So, talking about commission, discounts, profit and loss, etc. And all of these things I was exposing you to, these conversions that we did first, the percentages of a quantity, the increasing or decreasing by percentages, quantities as percentages, as well as this one we're going to do now, they are all tools that we have in our mathematical toolbox, which we will apply to problem solving, to real world applications of percentages. And I've left the unitary method for last because, in my opinion, it is the most powerful one. And it makes certain calculations a lot, a lot easier. Now, I have included, as our first example, a problem of percentages of a quantity. But I'm not going to solve it in the same way as I did in the last video, where I looked at, making this a fraction and then doing the multiplications. I'm going to solve this in a way that is using the unitary method. And I'm then going to go into other applications of the unitary method. So we want here to find 17% of 500, right? And like I said in a previous video, we can think of this quantity as our whole. So how do I get, without doing our um, our multiplying by a fraction, let's find out another way to solve this. Well, what I want to do is I want to get this 17% to 100%. Well, actually, no, I want to go the other way. I want to get this 100%, my whole of my quantity, to 17%. Because I want to find this kind of fraction, the smaller number of it. So I want to get this whole number, which is my 100%, to a number that represents 17% of that. So what I'm going to do here is I'm going to write that 100% is equivalent to 500 in the context of this question. Now, what is one way I can, well, probably because this 17 is an ugly number. It's not a number that is immediately, that can divide into 100. And it's not a factor of 100. So it's a little bit harder. But there is one really great way to get from 100 to 17. Now, some of you may have an idea, but we are going to condense our 100 to a unit, to 1%. Because once we get this to 1%, we can just multiply the 1% by anything to give us some number. So any number can be shrunk to 1%. We can make one out of any number, and we can make any number by using one, because one is a factor of every number, essentially. So what I'm going to do here, we have an equation here, but can't spell. I'm going to divide. Let me try that again. I'm going to divide both sides by 100. Because dividing 100 by 100 will give me 100% by 100 will give me 1%. And that, well, from what we know about equations, whatever we do on one side, we have to do on the other side. So I'm going to divide both sides by 100, and that'll give me 1% is equal to 500 divided by 100, which is 5. Now, this is really powerful, and this is an equivalent statement. The fact that 1% equaling to 5, an equivalent way of saying this is that 100% then would equal to 500. So we've just gone the other way here. And now that we have our 1%, we can multiply both sides by 17, because 1 can be brought to any number by just multiplying by that number. So I'm going to get, on my left-hand side, I'm going to get 1% times 17. And on my right-hand side, I'm going to get 5 times 17. So I end up with the statement that 17% equals 5 lots of 17, 5 times 17, which is 85. And you can check this answer by doing the other method before that we did for finding percentages of a quantity. You can actually check that to verify that. But let's actually think about what we've done here. We first, in doing both of these operations, we first divided by 100 and we multiplied by 17. But that's exactly what we did when we took percentages of a quantity. Remember, we said, okay, 17% of something, let's find that as a fraction, which is 17 over 100. And we just took that fraction lots of our quantity, which was this multiplication. So the unitary method is essentially what we've been doing this whole time when we have been taking percentages of some quantity. Now, let's look at why this is so powerful. This thing that we've essentially derived is really powerful for going the other way. Let me show you how. And this, obviously, you'll see a lot of in our applications, but this is pretty cool because this allows us to find that, well, if given some percentage, if given some fraction, we can find the whole. So this question I'm going to write is, if 15% of a number, some number, is 360. Try that again. It's 360. What is the number? Cool. So I'm going to do the exact same thing that I did before. Well, I'm going to say 15% of some quantity is 360. So to find what that quantity is, to find what my whole is, well, I just need to get this to 100%. Because 100% is the whole. If a fraction is something that if a smaller percentage of this number is 360, then I'm going to do a couple of mathematical processes to find what number makes up 100%, what number makes up that whole. And we can do the exact same thing because I can't get 15 to 100 very easily. It's not really a factor of 100, but I can get it to 1%, and I can get 1% to 100% pretty easily. This one is so powerful in mathematics. So here, we're just working the other way to what we did here. We want to first divide both sides by 15%, because that will give me an expression for 1%. And that will be 360 divided by 15, which is 24. You can check that on your calculators. And now that I have what 1% is, I can get this to 100% by multiplying both sides. I've just done these quotation marks here, by 100. Sorry. Actually, just as a technicality, I shouldn't have percentages here. Because dividing this 15% by 15 will give me 1%. And then multiplying this 1% by 100 will give me 100%. So I now have that, well, 100% is equal to 24 times 100, which is going to be 2,400. Guys, the unitary method is very powerful, and we've been doing it when we looked at percentages of a quantity without even realizing it. This is a powerful tool because the number one is a powerful tool. Now, we have all the tools. Let's consolidate these tools, and in the next few videos, we are going to look at applying percentages. And the unitary method especially is going to play a very key part, as well as all the other ones we've done. But I hope these videos have given you a strong foundation on the mathematics behind it. Now let's look at the applications. So I'll see you guys next time.